Question number 5. Discuss key features used within insulin expression cassettes to meet specific needs of the field. Consideration that must be taken into account when designing the insulin expression cassette are: Number 1. The promoter to drive insulin expression. Most common in gene therapy, cytomegalovirus promoters CMV. However, it would drive a consistent high-level expression of insulin even during fasting periods, resulting the glucose level to fall extremely low. So, instead of using CMV, a weaker promoter is used to maintain low level of insulin production during fasting period, and upregulating insulin when glucose level rise for treating type 1 diabetes mellitus. For example, weaker tissue-specific promoters have been used for hepatic insulin gene therapy application. It is because it not only reduces the risk of hypoglycemia, it also improves targeting to the tissue of choice.
Next, let's see the list of promoters for insulin gene therapy applications. First, glucose 6-phosphatase G6Pase promoter. The function is to drive insulin expression. To increase glucose concentration will enhance promoter activity. Under low glucose condition, insulin will inhibit G6Pase promoter activity, creating a system with feedback inhibition. Second, liver-specific GLUT2 promoter. The function is to drive insulin gene expression. Third, red insulin 1 promoter. It will create a system that is activated by both glucose and insulin. Incorporation of GIRS, which is glucose-responsive DNA sequence, will enable glucose-responsive control of gene transcription. Fourth, liver-specific insulin-like growth factor binding PS protein 1 GFBP1 promoter. It will generate glucose-responsive insulin expression. Researcher incorporated GIRS from the LPK gene directly upstream of the GFBP1 promoter. And last but not least, liver-specific albumin promoter. It will create a system that is unresponsive to insulin, but activated by elevated glucose level.